Hello then, welcome to Chemistry Made Simple. In this video I'm going to introduce you to isotopes. This will be suitable for GCSE level students. So we'll start off by covering what isotopes are, then we'll have a look at the similarities and the differences between them, then we'll have a look at the mass number that we covered in the Introduction to GCSE Atomic Structure video and the relative atomic mass, and we'll have a look finally at how to calculate a relative atomic mass. So a definition. Isotopes are atoms which contain the same number of protons but different numbers of neutrons. So if they contain the same number of protons, they've got to be the same element because it's the number of protons that determines what element we've got. Now remember, atoms don't have an electrical charge, so they've got to have the same number of electrons and protons. Now let's have a think about the atomic number and the mass number. We did that in the video where I introduced GCSE atomic structure. Let's have a think about argon. So Ar. Argon's got a mass number of 40 and an atomic number of 18. Now remember, the mass number is the number of protons plus the number of neutrons. And the atomic number is the number of protons, but since atoms are electrically neutral, the atomic number is also the number of electrons. So looking at these definitions then, an isotope will have the same atomic number but a different mass number. Okay, so let's have a look at chlorine. Now there are two main isotopes of chlorine. So if we put them here now. Now chlorine's got an atomic number of 17. If an atom's not got 17 protons, it's not chlorine. Every single atom of chlorine's got 17 protons. But one isotope's got a mass number of 35 and the other isotope's got a mass number of 37. So therefore, we can put in the number of protons, 17, and electrons as 17. Now remember, protons are positive, electrons are negative, but neutrons have got no charge at all. Now, to work out the number of neutrons, we get the mass number and subtract the atomic number. So 35 subtract 17 is 18 neutrons in this isotope, and 37 minus 17 gives us 20 neutrons in this isotope. So, same number of protons, but also the same number of electrons, but different numbers of neutrons. So let's look at that in a little bit more detail. Now, if we've got 35, 17 Cl and 37, 17 Cl, now we've got 17 protons in each nucleus. The number of electrons is also going to be 17. So remember, we put 2 in the first energy level. When that's full, we can put the next 8 in the second shell or energy level. And then we can put the final 7 in the third energy level. The other isotope is going to be exactly the same. Now the difference, of course, is the numbers of neutrons. So we've got 18 neutrons here and 20 neutrons here. Now, it is the electron arrangement, the number of electrons in each shell, that determines the chemical properties or the reactions of an element. So we would expect isotopes to have exactly the same chemical properties because they've got the same electron arrangement. Now, this isotope here, every atom's got 2 more neutrons. So every single atom's going to be a little bit heavier. So I would expect the physical properties to be different. So I would expect chlorine 37 to have a higher melting point and a higher boiling point, for example, simply because each atom's a little bit heavier. So there we go. We've got the same chemical properties, but slightly different physical properties. Now, some isotopes might be radioactive, and you can get that, for example, in hydrogen, or certainly in some of the heavy metals like uranium and plutonium. Now, looking at the two isotopes of chlorine one final time, I'm going to show you the difference between the mass number and the relative atomic mass. Now remember, the mass number, this top number here, is the number of protons plus the number of neutrons. Therefore, it's got to be a whole number. Now, if you look in the periodic table, you'll see that the mass number for chlorine is shown as 35.5. Well, that's because it's not the mass number, it's the relative atomic mass. Now, the relative atomic mass is a weighted mean, if you like, a weighted average, that takes into account the percentages of the isotopes. Now, if we had a look at a large number of chlorine atoms, we would find that 75% of them would be the 35 isotope and 25% will be the 37 isotope. Let me show you how to calculate the relative atomic mass. So we do 75, multiply that by 35, bracket those together and add it to 25 multiplied by 37. If we divide that all by 100, because of course they're percentages, we get the relative atomic mass, which is 35.5. And the relative atomic mass often isn't a whole number, but it's a weighted mean or a weighted average that takes into account the percentages of the isotopes. Now, the relative atomic mass doesn't need a unit. Now, we often give these numbers their own little symbols. So the mass number is given the symbol A. The atomic number is given the symbol Z. And the relative atomic mass is given the symbol AR. So capital A with a little r next to it. Now, if we look at magnesium, slightly more difficult because magnesium's got 3 isotopes. Now, the atomic number must be 12. If it's not 12, it's not magnesium, because every atom of magnesium has got 12 protons and 12 electrons. The 3 mass numbers are 24, 25 and 26. Now, you may want to have a go at working this out yourself, in which case put this video on pause, but I will show you how to do this in a few seconds. So what we do, we would get 79 and multiply it by 24, bracket those together, add it to 10 multiplied by 25, and finally add it to 11 multiplied by 26. If I divide that lot all by 100, I will get the relative atomic mass at 24.3. So that's isotopes, hopefully made simple. Thanks for watching.